Hello everybody. We are today in this class we are going to discuss Monte Carlo method. It is a method you generally use for obtaining the integration, numerical integration, and it is also a method used for obtaining the determining the value of pi. So, generally a question arises like why the name Monte Carlo? It is related to the one who proposed this method. It's like this method is related to some sort of gambling. The one who proposed this method used to go for this gambling in casinos and all. So the name of one of the casino was Monte Carlo, and he just coined the name from there. It is some related to some sort of gambling. And while discussing this problem, it will be more clear to you. Okay, it is like the aim of this Monte Carlo method is to determine the value of pi using random numbers and plot how you're going to get it using the random numbers. And one more question is there, determine the value of pi using Monte Carlo method. Tabulate the values for every 2000 intervals of iteration. Tabulate the value of pi for every 2000 intervals of iteration. Uh, like and print iteration from 1 lakh to 2 lakh. Okay, it is specifically given, and during your fourth semester you will be having practicals, one practical paper named computational physics, and in that paper you will have to study this two aims and all. So that's why I have included it here also, so it will be easy for you while doing your practicals in the fourth sem. All the practicals that you generally this sort of questions will be there in your practical exam question paper. So I'll discuss this last module in the same manner, so it will be easy for you in your fourth semester. Okay, so next question is determine the value of pi using Monte Carlo method. Tabulate the value for every 20,000 interval of iteration step from 1 lakh to 2 lakh. It is given there. So in this problem, first we consider a unit circle. Unit circle means the radius of the circle is unity. You can assume this circle. Unit circle centered at our origin and unit square in the first quadrant. And we'll just cut the circle into 4 quadrants such that you can assume a unit square. Unit square means all sides are having length unity in the first quadrant of the circle. So I can, if this point is assumed to be origin, I'll get the coordinates as along x-axis it will be 1, y-axis it will be 0, and here the coordinates will be along x-axis it will be 0, y-axis it will be 1, and this point, you can assume this point, here the coordinates will be 1, 1. That means it is a unit square. So it is given the condition here 0, x less than or x is between 0 and 1, and y also is between 0 and 1, and the equation of the circle is what? X square plus y square is equal to 1, and we are assuming the first quadrant of the circle, and within the circle, within the unit square, a sector is inscribed having what the side length as 1. Okay. Okay, so what is the area of the circle? Area of the circle is pi r square. And the area of the sector means here r is the radius, and the radius here is 1. So I can write here r is equal to 1. So what happens? The radius become pi. R is equal to 1 means it is pi. Then you can write the area of the sector is what? It will be pi into r square by 4, that is pi by 4. I'll name it as m, that is area of the sector is m. And what is the area of the square? Side into side, that is 1 square, that is 1. And I'll name it as n. So if you are putting m by n, what you'll get? M by n is equal to pi by 4. And you can get the value of pi as 4 times m by n. So this is the method that you're going to follow here. Okay. So what you're doing here is, you just consider this portion only. You consider only this portion. And you're continuously throwing the balls to this region. You're continuously throwing your balls to this region. Okay. So you cannot say in which region, at which point the ball will fall. I can show it to you more clearly using the plot. Okay, I can show it to you more clearly using the plot. Okay, this is actually what's happening. So I'm throwing this. If we assume that there is a board of unit square, it's having 1 meter length and 1 meter breadth, and within this board, a sector is inscribed within the board, and I'm continuously throwing balls on this board, and you're marking the points where the ball falls. Suppose at the first in your first throw the ball falls at this point which is outside the sector but inside the square. Okay, so what happens, I'll mark it with a point, and next is then I'll put a condition. If the ball is falling inside the circle, I can give a condition, what, x square plus y square is less than or equal to what, that is the equation of the circle. Okay, and the sector is a part of the circle, then I can give a condition x square, if x square plus y square is equal to 1 means the ball is falling inside the circle, and else the ball is falling outside the circle, and I'm continuously marking all the points. And if I'm throwing the ball 100 times, you will get random points in this whole area. And what is next is that I'm continuously throwing the balls continuously, such that what happens, this whole area will be covered with dots. And if I'm doing it 1 lakh times means I cannot see the board, means every each and every point there will be point and point and point, the whole area will be covered with a point. Okay, this is the basic of this we are going to do. And okay, now what you're doing this, if you're throwing the ball such that it falls here at the within the circle means I'll give a value for m, and if it is outside the circle means I'll give a value for n. N means the number of throws. If you're throwing n number of times, always it will be within the square. But the condition to be within the sector is what? X square plus y square should be less than or equal to 1. If that condition is satisfied, I can increase the value of m. For each number of throws, I can increase the value of m. Okay, so we'll repeat the process 1 lakh or 2 lakh times so that you will get a lot of values for m and n. And if you are just finding the ratio of m by n into 4, what you'll get? You'll get the value of pi. Seems pretty interesting, right? If you are throwing the ball 1 time, then n is equal to 1. It falls outside the sector. Then the value of n is equal to 1. Then you throwing the ball next time. Then the value of n is equal to 2. But still, in this case also, the ball is outside the sector. So, no value for m. M is again 0 here. And third term, if I'm throwing the ball, it falls within the sector. Now the value of n is 3, the value of m is 1. And I'll do it 1 lakh times. So you'll get pretty good values for m and n. Okay. This is what you're going to do. So it is the algorithm. First one is start, define, and here what we are doing. Throwing the ball means you will get some values for x and y. Right. My point is here. Okay. My point is here. The point where the ball is thrown is here means it will have a particular value of x coordinate and it will have a particular value for y coordinate, and it is such that its value lies between 0 and 1. So here what you are doing this, you are generating random numbers. Random numbers means it takes values between 0 and 1. We could not predict what will be the random number generated. There will be a seed program inside the PyLab, inside the core Python module, we generate random numbers and we are not aware of the number what is being generated. So we call this random number 1 lakh time, and each time what happens, it gives a specific value which is between 0 and 1 for x and y. Okay, so we are calling the random numbers. Define m, the number of random numbers. Set n is equal to 0. Set x dat and y dat means we'll have to plot it. For I in range M, what you doing? Okay, may I look may I just have a look at the program. M is the count of the random number. Okay, here when it is within the uh, circle means, okay, what I'm doing is the count of random number generated is n. That is the number of throws. Okay, M. Define n, the number of random numbers generated. For I in for what I equal to 1 to n, do that is enough. For I is equal to 1 to n, do that is the loop repeats, iterates n times. N is the total number of throws, that means total number of random numbers to be generated, and so that when I is equal to 1, a random number is assigned for x, another random number is assigned for y, and you check whether x square plus y square is less than or equal to 1. Then what happens? The value of, if it is true, value of m changes to m is equal to m plus 1, and you will append what? X to x dat and y to y dat, and you will get value of pi to be into m by n. Okay, this is consistent with the theory that we have written here. M by pi is equal to 4 into m by n. Okay, plot x dat and y dat. Okay, so if you're discussing the program, it will be more clear for you. That is, first step is we'll have to import pylab from pylab import star, and here I'm going to change it as n is the number of count of the random numbers or number of throws, n number of throws, and I'll assign m is equal to 0, x dat and y dat is list, that is for the purpose of plotting, and for I is equal to 1 to n, x is equal to random, y equal to random. That is, I will take a value 1 and up to n. If I am giving it as 10 lakh, I will repeat from 1 to 10 lakh times, and in each of these times, a random number is assigned for x and y values. Then you check the condition. If x square plus y square is equal to 1, that means it falls within the sector. And now what happens? If it is falling within the sector, the value of m becomes 1. And this process is repeated. And x value is appended to the list. And similarly, y x dot append x and y dot append y. This x and y values will be, and here no need of numbering. It is done by mistake. So it is actually the program, and no need of numbering the program. Okay, and each of this time x and y values will be appended to the corresponding list. Then you can print the value of y. Then you can plot it. We need title, x label, y label, x label, y label, plot x dat, y dat with a dot. Then only you'll get all the dots. That is, it is actually gives the point where we throw the ball, then show. Okay. and the output will be value of pi is 3.1400, and you'll get the output like this way. It just gives us the point. Okay, x dot y dot with a dot. Okay, hope this is clear for you. And here I'll have to change the value of pi is, it is m by n. You go through this program, you try to run this program using the link that I've given you. Okay, need to study only this program. I have cut out the second program for you. Okay, even though the question is there, I better, it will be confusing for you. There is one more question like this way, and it won't be asked for your theory paper. So to avoid confusion for you, we'll discuss only one program. I have avoided the second aim. Okay, this much is enough for you. You just go through this, and here I'll look at the algorithm once more. It is start, then define the number of throws, that is the number of random numbers. Then I'll set m is equal to 0. Then I'll initialize. It is rather than using set, I'll use initialize x is equal to 0. Similarly, I can write initialize x dot and y dot i for I is equal to 1 to n do. We'll assign random numbers for x and y. Check whether, no need of 2, check whether x square plus y square is less than or equal to 1. Then m becomes m plus 1. Append x to x dot and y to y dot. Then print the value of pi. Then plot x dot versus y dot and stop. It is easy. It is one of the simplest programs, and it is very easy to code without much confusion. Okay, x square plus y square less than or equal to 1, m is equal to n plus 1. And here I am appending these values. Okay, to get all this sector colored blue, what I have to do to differentiate the sectors? If I am putting this x dot append x and y dot append y outside the loop, means what happens? I'll get everywhere blue colored. So you cannot differentiate what is the sector and what is the square. To make the plot clear, for you to differentiate between the sector and the square, I have put all the values for m satisfying the condition that x square plus y square less than is equal to 0. That is, all the points lying within the sector is only plotted. That is why this x dot append x and y dot append y is within the second loop, where the condition for the circle is satisfied. If I am putting it outside this loop, what happens? All the points will be marked as blue. These points will be marked as blue. So you will get a complete square in blue color. So it won't be easy, or it won't be appealing, or it won't be like comfortable for you to understand. That's why I put this x dot and y dot within the loop. Okay, so hope the program is clear for you. If you are having doubts, you can ask me. The follow up you have to do is, you just try to plot this and get this plot and get the value of pi and send it to me as screenshot. Okay, I'll send you the date for doing all these programs and sending me the screenshots. So okay, thank you. I'll come with a new program soon.